On the back, the three problems at the top are really going to help you understand the properties of logs. And it's not a proof of them, but it is going to verify them for our purposes at least. So I just want to show you something that's really cool, in my opinion. Log of 10, by the way, that's 1, plus log of 6, by the way, that's a decimal. Log of 10 plus a log of 6 is 1.7778151510. That's my phone number. And then if we do the log of 60, we get, oh my goodness, we get the same thing. So on the paper where it said confirm, there's really nothing to confirm. I just want to use this to demonstrate something to you. This is cool. Watch this. Don't miss this question. I'm going to point at the answer. What's 10 times 6? Ooh. Okay, so here's what it means. When I'm simplifying logarithms, if you have a big, ugly, nasty mess of logarithms like you do down here, somebody walks up to you on the street and hands that to you and they said, hey, simplify this, you'll know how to do it. Whenever I am adding logarithms, I can simplify it by multiplying them. Okay, you can probably tell where I'm going with this next, and so I'm going to spare you the trouble. What is 100 divided by 50? I believe it's 2. That's wonderful. So when I'm subtracting, I will divide. So what I really could have written is this. Log of, let's just simplify the 100 and the 50. So 100 divided by 50. Log of 100 divided by 50. Well, 100 divided by 50, that's the same thing as 2. So it's really the log of 2. Same thing. I could have done the same thing up at the top. I could have been like, well, let's see, 10 times 6. That's really the log of 60. It's the same thing. Exact same thing. Let me kind of recap, because this stuff is a little crazy if you're not careful. It's crazy whether you're careful or not. If you are adding logarithms, you can turn it into one log by multiplying the numbers together. If you are subtracting logarithms, you can simplify it. You can make it a little shorter by dividing 100 divided by 50. Here's the next one, and it's the craziest, but it's the most practical. Check this out. You could take that 2 if you wanted to. You could move that 2 up here, and it could become an exponent, which would really mean that you have this. You have the log of 5 squared. I know what 5 squared is, and you do too. 5 squared is 25. There you go. So, again, I'm sorry to repeat myself so many times, but I just want to make sure you got it. When you are adding logarithms, multiply. Create one log and multiply. When you're subtracting logarithms, create one log and divide. If you have a coefficient, the number in the front, move it up and it can become an exponent. And it works perfectly well. All those are written in good plain math language right there. I know this may look a little confusing, so I'm going to go through the next 6 problems. And yeah, I think I'm going to use a separate piece of paper. So I can write it nice and big. Okay, so we're going to start with number 23. Number 23 says, 23. Can y'all see that okay? Probably not. Here, let me slide that down just a little bit. Number 23 says log of 5 plus the log of x. Okay, here's what I notice. I'm adding logs, and it is a mess. And I don't like it. I don't like the way it looks, and I want to simplify it. So the best thing I can do is create one log by multiplying these two parts right here. 5 times x. Last time I checked, that was just 5x. This is correct. That's even better. Let's put it in parentheses. I won't count off if you don't, but it does look better. What I'm about to say doesn't seem to apply to this problem, but it's going to come in handy on the next problem. I want to point to a number. I'm pointing to a 10 right now. It's an understood 10 that you didn't have to write. And there's an understood 10 right here as well. And there's an understood 10. In the process of adding these logs, this is so important. In the process of adding these logs, I did not change the base. This number is called the base. It did not change. Don't look at these and say, well, 10 plus 10. Let me tell you, in this case, 10 plus 10 is 10. It's not really, but the base does not change. Do not change it. Stays the same. So if you're looking ahead to number 24, whenever you are finished, you're going to have that little 4 floating around. Let's quit talking about it and just do it. Number 24. You have the log base 4 of 5 minus 2 times the log base 4 of x. Let me point out a couple things, and then I'm going to tell you where we should start this problem. There is subtraction. Because of this subtraction, we are going to divide, but don't go there yet. The first thing you should do in any of these problems, and it really didn't apply up here, but the first thing you should do is move your coefficients and make them exponents. Do that first, all day, every day. Well, I wouldn't do that all day. You would need to do something else other than logarithms all day. Log base 4 of x squared. Now it's a little cleaner. Your coefficients are out of the way. But it's still a mess. And the best way to get rid of a mess is to consolidate. When we are done, we want to have one log. Just one good old-fashioned log sitting right there. That log is going to be a base 4 because both of these are 4s. There's a question some of y'all are about to ask right now, but the screen's not going to respond. I'll answer it in a minute. Hold on to your thought. Since both of these are 4s, that's going to be a 4. We're going to divide, and we have this. I'll put it in parentheses. Okay. That is correct, and we are done. I know I'm done because I have created one log, and there's nothing else that I can combine or consolidate or simplify. The question some of y'all were probably thinking, maybe not, maybe so, was I pointed to these and I said, because these are the same, we can put them together. Your question might have been, what if they are different? Then you can't do anything with it. I don't plan on ever giving you any problems like that. But just in case, a guy walks up to you on the street and hands you the stuff. If you've got a 4 here and this base is a 6, for example, then there's nothing you can do to put these two together. You could move that coefficient if you needed to, but you can't subtract them, you can't add them, you can't combine them like that. They have to have the same base. Okay, number 25. Log base 2 of 30. We'll pause right here. If you want to stop here and look through the rest of the problem, you'll realize that all of them have a base of 2, and they better, otherwise we're going to have issues. Log base 2 of 30 minus log base 2 of 6 plus log base 2 of y. Okay, let's go back to number 24 and point for a second. The first thing I did was move my coefficient. That's always the best place to start on these problems, is to move your coefficient and let it become an exponent. So I look for coefficients. Coefficients are the numbers in front. Not here, there's nothing here, there's nothing here. So I don't have to do that first step. I will later on other problems, but I don't right now. What I will do is just take care of these just 2 at a time. Don't try to cram them all together at once unless you really know what you're doing. But let's put these two together, and because these two are subtracted, we're going to divide. So we really have the log base 2 of, let's divide these, 30 divided by 6. If you want to skip this step and go ahead and put a 5 right there, feel free. Go for it. Log base 2 of y. We're going to divide. Dividing those two gives us a 5. Log base 2 of 5 plus log base 2 of y. Okay, we have simplified almost completely. We are not done because we still have 2 logs floating around, and we can combine them. And we will combine them with, don't let this trip you up, we're going to combine them with multiplication. I know I'm pointing to addition, but it's one of the properties of logarithms that you can multiply things that are added. So it's really 5 times y, which is just 5y. Number 26. There are 3 more. Okay. Oh, the next one has that crazy exponent, or the crazy coefficient. Number 26. 1/2 log 49 plus log x minus log y. Okay. One thing, kind of unnecessary, but I want to point it out. All of these have a base of 10. It's an understood 10. Not going to do much with it. Actually, not going to do anything with it. It doesn't change. It remains there, and it remains unwritten. Whereas on the last problem, we had a base of 2 or a base of 4 on the one before that. This one's a 10, stays a 10, doesn't get written. What I do look for first are these little guys right there. I like to circle them, and I like to make them exponents. Don't be afraid to rewrite the problem a couple times to get it to where it needs to be. This is 49 to the 1/2 power plus the log of x and minus the log of y. Okay. Don't panic. We mentioned this in a previous video. If you don't remember it, you can go back and look at the video. What I'll tell you right now, 49 to the 1/2 power is the same thing as the square root of 49. That is 7. So what I really have here, let's write it again. That's 7. That's log x. That's log y. I'm going to speed this up just a little bit. I will add those two, log of 7x, and then I will divide these two. And when you divide, you're consolidating. You're creating one log out of this thing. So log 7x over y. We are done. Okay, there are 2 more problems. Let's keep moving. You may want to try them on your own, so feel free to pause the video. 3 log 9, 4. All kinds of numbers floating around. Don't let that trip you up. You got to know where to put them. Okay. What do you want to look for first? Boy, I hope you just thought the word coefficient. There's a 3, and he's going to go there. There's a 2, and it's going to go there. Log base 9 of 4 to the 3rd power plus log, that 9 doesn't change, and it's x to the 2nd power. Okay, let me tell you what some of you might be thinking. Some of you may be thinking, well, I'll add them since I'm adding, I'm multiplying. Yeah, great, whatever. Don't go there yet. Not yet. We're not quite there. Not until we figured out what 4 to the 3rd is. 4 times 4 times 4, 3 4s, that is 64. So what we really have is this. Okay? Because we are adding, we will multiply. That 9 does not change. 64 x squared. Because there's a couple pieces to it, a couple factors, I'm going to put it in parentheses. Okay, one more problem, and it's a beast, but it's not that bad. Trust me. Actually, it's relatively easy, and it's going to simplify pretty well. It's going to look a little crazy at first, but it's going to simplify pretty well. So 28, 2 log x plus log 4 minus 3 log x plus log 2. Okay, I'm going to go fast. I'm going to start with the obvious. Hope it's obvious. Don't let those parentheses make you mad. Parentheses never hurt anybody. Log x squared plus log of 4 minus parentheses log x cubed plus log of 2. Okay, here goes. Parentheses come first. So we'll go ahead and put those together. And by putting them together, because we're adding, we will multiply. I hope you said multiply. Log, understood 10, don't worry about it. 2x cubed, x cubed times 2, which would be 2x cubed. I want to put it in parentheses. There was a subtraction in front of that. To reduce the number of steps necessary, in a minute I'm going to have to put those together anyway. So I may as well go ahead and do it now. Even though there are not parentheses around them, it's going to have to happen in a minute, so let's do it now. Log, adding means multiplication, so x squared times 4, that's 4x squared. We will now divide. This one's going to get a little bit crazy in just a second, but it's not that bad. We have log of this guy divided by that guy. So 4x squared over 2x cubed. Running out of room on the bottom of the paper. Let's simplify it. You're like, simplify it? I'm done. Oh, think about it. You have a fraction, 4 divided by 2. You know what 4 divided by 2 is. It's 2. But let me tell you what else you know. If you have x squared on the top and x cubed on the bottom, I really hope this looks familiar to you, what I'm about to write. If I have x squared on the top and I have x cubed on the bottom, and I go crazy canceling things out, dividing out those, it leaves me with an x on the bottom. The shortcut you learned back in the day was this. 3 minus 2 gives you 1. I'm left with 1 on the bottom. There you go. There's your final answer.